Here I have a couple of 16-gram dominoes balanced on a strap that can rotate on top of a plastic die until it falls off. Now, my question then is, what are the moments of inertia of these two dominoes? And also, I've added another domino. What's the moment of inertia of this domino? We're going to assume rectangular dominoes. Let's just do one domino. Surface area of the top is about 12 square centimeters. The mass is approximately 15 grams. So the density is constant, and it's equal to what? 15 grams over 12 square centimeters implies 1.2 grams per square centimeter. Now let's assume that the axis of rotation is right here. And the domino is out here along an axis that we'll call the x-axis. And that the domino extends from x equals 8 centimeters here to x equals 13 centimeters here, and also that it extends that its width is 2.5 centimeters. And I'm not going to write down the assumption of symmetry. We assume that it's symmetric with respect to the x-axis, so that the region occupied by the domino is the rectangle 8 less than or equal to x less than or equal to 13 and negative 1.25 less than or equal to y less than or equal to 1.25. We want to find the moment of inertia of the domino about this axis. Now, I want to go ahead and draw a little bigger picture of the domino up here. And put our axis here. Don't have real good symmetry there, but we'll try to live with that. We're going to partition our x-axis from this point to this point. So our x partition is 8 equals x naught less than x1 less than etc. less than xi minus 1 less than xi less than etc. up to 13, with our numbers represent our positions in centimeters. So we've essentially broken the x-axis into a bunch of intervals, and we've in the process implicitly broken the domino into a bunch of vertical strips, this being a typical strip, and let's call this the ith x interval. Similarly, we can do a y partition which would be negative 1.25 equals y naught, which is less than y1, which is less than, etc., which is less than j minus 1, less than yj, less than, etc., less than y sub n m, which is equal to 1.25. So now we've divided our y-axis, our y direction, into a bunch of intervals. If we consider our origin to be here, then we've partitioned the interval from negative 1.25 to 1.25. A typical interval in the partition might be this one. Call this the jth interval. And this interval corresponds to a horizontal strip.